Hello, I'm Grant from Makers Vlog, and today I'm talking about 5G and more importantly why it's so much faster than 4G. Now, if you haven't seen, I did another video on explaining what 4G, 3G, 2G and all them were. I would suggest you go see that. If you don't know, go see that first and then come back. But if you know, happy days. So, why is 5G so much faster? Well, the 5G standard states that in order to be 5G compliant, you must be able to get a theoretical speed of 200 gigabits per second. And that's theoretical, so that's in ideal circumstances, you could get 20 gigabit per second. Real world tests have not been close to that, but the theoretical speeds are, so they can be called 5G compliant. The frequency spectrum is around 400 megahertz to 28 gigahertz. Now this is location dependent. So that I believe is true for America. There are some places, I think in Asia, where it's somewhat more restricted. I think it's lower down in the frequency is where they cut off. The tests that have been done so far, the speeds have been around 80 to 900 megabits per second. And that's dependent. It's near a complete correlation to the frequency that you're on. Lower frequencies, less speed. Higher frequencies, more speed. And there's reasons for that. With 2.4 gigahertz upper bandwidth, they could have massive chunks of the spectrum allocated to them. They can use large areas to send the information. And because they have larger chunks of the spectrum that they can use at any given time, they can send more data. That's one reason. The other is technology. So the technology is getting better, but 28 gigahertz is in the microwave frequency range. It's very high up there, so it is low, or it can be low power, but the antenna size is also small. This allows them to use large MIMOs, multiple input, multiple output antennas. These antennas are able to communicate with multiple devices very effectively, and they essentially replace the need for having lots of antennas. And this has been around since 4G. Because the antenna size doesn't need to be as large, they can make larger clusters of antennas in the same space to handle more communications more effectively. The 5G technology standard is 5G NR, New Radio. That is the technology standard that have been making these antennas and doing the software for it. There are a few others in different countries, but that is the primary one. So it can handle this massive data transmission because of the microwave frequency, because of the technology. But what are the downsides? And there are a few. So you might have noticed, okay, that's microwave frequencies. Is that microwave as in the thing that you have in your kitchen that heats up your noodles? Yes, it is. And a lot of people have been panicking about this and saying, am I going to get microwaved if I stay near one of these masts? And if you're right beside it, yes. But that's it, you have to be right beside it. Microwave frequencies are very short range and they lose their power over distance very rapidly. The power of a tower is 1 kilowatt. So if you think of your microwave, most of them are around 800 watts to 1 watt. 700 watts to 1 kilowatt in some extreme cases. So it's not that much more powerful than your microwave. And if you think of your microwave, it's all contained. And the reason it's contained is one, for safety, but two, it stops the power escaping because it would very rapidly and it wouldn't actually heat your food. So the towers will have more than likely a fenced off area around them with a minimum safe distance. And that will be exaggerated. So, sake of argument, if you need to be 50 meters away from the tower to be out of harmful microwave range, the exclusion zone would probably be about 200 meters or so to make sure that no one gets that close to them. Now, you might be thinking, okay, well, if it's very short range, how does it actually get to your phone? Are they going to need a lot more towers? And yes and no. As I said, the antennas for these are very small, as is the power level required to effectively do a repeater. The towers are 1 kilowatt to actually get a nice broad signal out. But once it's out there, repeating it it doesn't need to be as high power. So they have a thing called small cells, which are essentially repeaters, small repeater devices that they can put everywhere. They're very low cost, low power, and because they're low power, they wouldn't actually pose a danger to human health. And by dotting these around, they can then expand the 5G network a lot easier. They also use technology called beamforming, which you might have seen in your Wi-Fi hubs. Some of the high-end hubs market this as a feature. And all it does is it makes an omnidirectional antenna, which is what most of them usually are, the sort of straight up in the air ones. They radiate in all directions. It turns it into a directional antenna, and by doing so, it gets extra signal out in the direction that it wants because it's not wasting any behind it. And that's all beamforming is, and the 5G towers are going to utilize this technology as best they can to then go, okay, say it's mounted on top of a hill, and there's a town down there, and there's nothing off into the distance. It can then form a beam to that town to get extra distance so that they don't need to dot a lot of repeaters in the way. Now, one of the big drawbacks with microwave frequencies is that it can't get through solid objects well. If you think of your microwave, there's not a lot to it that actually stops those signals getting out. And the same is true for your house. So I think 5G signals, you're probably going to see a lot of repeaters being sold that you can put an antenna outside of your house and have a repeater or another antenna inside your house that then blasts the signal inside the house to get past the wall, because 5G at the upper frequencies, at the higher spectrum, will not be able to get through walls. Now, that's not to say that you won't be able to get 5G in your house, because as I said, the frequency range is 400 megahertz to 28 gigahertz. The lower frequencies, the UHF ranges in that, will still be able to get into your house. So if you're in your house and you have 5G, but you notice it's being quite slow, it's because it will have been using the lower frequency to get through and get into the house. The upper frequencies will be blocked by the walls and concrete in the house. So if you want the faster speeds in your house, you would need an antenna externally to boost that signal. So that's a big drawback to it. Now, some companies will stick to set frequencies. So in which case, if they can't change between the two, then you will also have issues. So that's it. That's why 5G is faster. A combination of technology, so better receivers and transmitters, using the higher frequency on the spectrum, the 24 gigahertz range, and allowed more bandwidth on that, and with the utilization of a lot of smaller repeaters, which allow a lot more data to be sent at one time. So that's it. So if you liked, please like, subscribe, all that good stuff, and I'll see you later.